All right, welcome back, everybody, for another deep dive. Today, we're going where no podcast, I think, has gone before.
Oh, is that right?
I think so. I hope so, at least.
Yeah.
Um, we're going to be talking about the future of humanity in space,
Okay.
specifically becoming a multi-planetary species. We found this really fascinating article called Humanity's Future, Becoming a Multi-Planetary Species, and it really just digs into the possibilities.
It's a really good one.
It is. It's really good. And the challenges, right, that we would face trying to colonize space.
Yeah.
Um, and so one of the things that it brings up right off the bat, I found this fascinating, was this idea of the Sputnik problem.
Okay.
I was like, what is the Sputnik problem? You know, we've been launching things into space since, what, 1957? You'd think we would have figured some things out.
Right.
But it turns out since Sputnik launched every space mission,
Well,
has relied on bringing everything from Earth.
every single thing.
Every single thing. And so I'm starting to think about like, okay, if we're going to colonize space, talking long-term missions here,
Right.
we've got to bring, habitats, food, water, tools, all of the equipment for life support.
Everything.
It just sounds like an impossible task.
Yeah, and this is something that the article talks about. It's just logistically a huge, huge problem, and the cost.
I was just thinking about the cost.
Yeah.
Like even launching a kilogram of, I don't know, let's say potatoes into orbit is going to cost thousands of dollars.
Yeah, at least.
At least, right? So, I mean, you think about what it would cost to launch everything we need for a Mars mission.
Yeah, it's really just not feasible.
Yeah, not at all. So the article emphasizes this idea that we've got to utilize space resources.
Yeah, we've got to live off the land, so to speak.
We've got to be resourceful, right?
Exactly. And the article kind of makes this in comparison to like the pioneers,
Oh,
settling new lands. They had to adapt and learn how to live off the land, use what they could find.
yeah.
And it's kind of, the same concept, but just on this massive scale, our new frontier is,
Celestial bodies.
celestial bodies.
Yeah. Okay, so where do we even begin? So the article talks about things like these free-floating space habitats, and to me that just sounds like something out of Star Wars.
Yeah, it definitely sounds like science fiction, but there's a lot of real science behind it.
Yeah.
You could imagine like these giant structures that are, out in space and they're rotating,
Oh,
and the rotation creates artificial gravity through centrifugal force.
that's pretty cool.
Yeah, which is something that you're not going to have on, the moon or Mars, which is something that people are concerned about, long term for human health.
Oh, that's interesting.
Yeah.
But I also imagine that living in a giant, I'm picturing like a giant cylinder spinning in space.
Yeah.
That's going to come with its own challenges, right?
Oh, absolutely. I mean, precision in those kinds of environments is going to be key. Even the smallest miscalculation could have,
Catastrophic consequences.
catastrophic consequences. Yeah, it's a big deal.
High stakes, high stakes. So then the article, talks about, well, the first step maybe in becoming multi-planetary is using the moon
Okay.
as like a stepping stone. So using the moon for things like solar energy,
Right.
maybe mining resources from the moon. And then there's this concept of terraforming, which that's where it really,
That's where it gets a little crazy.
it's like, come on, how are we going to terraform the moon?
Yeah, and terraforming in general is just this huge undertaking.
It's huge.
Transforming a celestial body to make it more Earth-like.
Right.
It's, we're just scratching the surface in terms of what we know about how to do that.
Yeah.
But it is interesting, the moon does have a very thin atmosphere.
Oh, does it really?
It does, yeah. It's mostly from natural processes.
Okay.
But human activity has actually contributed to it a little bit.
Oh, wow. So we've already had an impact.
We've already started, yeah.
That's pretty wild. So speaking of transforming planets, the article spends a lot of time talking about Mars. And why is Mars like the ultimate goal? What is it about Mars?
Well, it's interesting, Mars is similar to Earth in some ways in terms of its land area. It's actually very similar to the amount of land area on Earth.
Okay.
And the length of a day is just a little over 24 hours.
Okay.
So it's pretty similar to Earth in some ways. And some scientists think that with enough effort, we could actually terraform Mars, make it much more Earth-like.
So we're talking like potentially oceans and
Yeah. Thicker atmosphere, liquid water, the whole 9 yards.
that's amazing. How would we begin to do that?
Well, the article talks about potentially increasing CO2 and water vapor on Mars. And so the idea is with enough CO2 and water vapor, you could thicken the atmosphere, trigger a greenhouse effect, and then that would lead to warmer temperatures, potentially liquid water. But of course, this is all theoretical, and the ethical
Well, of
considerations
course,
of
yeah.
something like that are huge.
I can only imagine, yeah. Something else that I found really interesting in this article is that it actually makes the argument that humans are better than robots for space exploration.
Okay.
And, I'm like, wait a minute, I thought robots were the future.
Yeah, and that's a pretty common misconception. And it's true that robots are great at following instructions and
Well,
collecting data, but humans, we have this ability for intuition and observation that robots, at least so far, can't really replicate.
right.
So, for example, imagine a geologist exploring a Martian canyon. They might spot a really unique rock formation or mineral vein that a robot, that's programmed to follow a specific path, just wouldn't even notice.
It would just miss it.
It would just miss it completely. And
Mm.
so there's this element of, human intuition and being able to adapt and respond to the unexpected
That robots just don't have yet.
that very West just don't have. Exactly.
Yeah, that makes a lot of sense.
Yeah.
Um, and that kind of brings us back down to Earth here, where things are already changing in
Yeah.
terms of space exploration, right? You have private companies now that are launching their own space programs.
Right.
Space tourism is becoming more common, and the article even talks about how there are people of all ages training for space flight,
Yeah.
like people in their 20s, people in their 80s. So it really is becoming more accessible.
It really is. Yeah, it's no longer just, governments running the show. And that opens up a whole bunch of new questions, I think, about the future of space
Mm,
exploration
it
and
does.
how we interact with these new frontiers.
It really does. So we've talked about space habitats. We've talked about utilizing resources on the moon. We've talked about the possibilities of terraforming Mars, the unique value that humans bring to space exploration.
Right.
It just seems like there's so many paths that we could take.
Yeah, there's a lot of possibilities out there, and I think, the choices we make now are really going to shape the future of humanity in space.
Yeah, it really makes you think, like, if space travel does become, as commonplace as air travel is today,
Right.
what kind of future are we creating amongst the stars?
Yeah.
What are we doing here? It's really something to think about.
It's an exciting time.
It is an exciting time. All right, well, that's all the time we have for today's deep dive. We'll see you next time.